So we have the definitions now. There are building blocks toward this path of autonomous automated, and really those are safety technologies, active systems, advanced systems. I know that that's very much what Bendix, what you're involved in. So why don't we take the next step here from the definition and walk us through what I like to call, and I stole this term, so forgive me, but the building blocks of where this is heading.
Absolutely. Well, let's start with kind of the basics and what we call the 5 I's of active safety and future autonomy. And when you think about any system, whether it's a stability system, a collision mitigation system, or an autonomous vehicle, these 5 I's are important in that development. And the first I is information. And this is what comes into the vehicle either from sensors on the vehicle, or it can also be information such as GPS or vehicle-to-vehicle, vehicle-to-infrastructure communications that come into the vehicle. The second I is intelligence. This is the smarts that exist in the electronic control unit. These are the algorithms that are going to take that information, process it, and determine if we need to have the third I in intervention. So in intervention, what we're doing is we're doing speed and direction variation to help mitigate a particular situation. So today with stability, for example, we are able to intervene by applying the brakes on the steer, drive, and trailer axles. And we can also help the driver, because of the way we apply the brakes on the steer axle, to help the vehicle go where they need it to go. It's not steering per se, but it does help. Then insight. All these systems are providing information or data that comes off the system that the fleet can use to help train drivers and do more. Last I is integrity. And quite frankly, this is the one we added the most recently. It used to be just the 4 I's. But the 5th I, integrity, really ties to ensuring that the other 4 I's are delivered and working with confidence and pure, if you will. We're avoiding outside influences such as hack systems. You know, it involves cybersecurity to make sure everything's going to work the way it's supposed to work. So when we start with those, then we get into kind of where we see the evolution of these technologies going. And it all starts with, it all started with ABS when it really comes down to it. With ABS, what ABS did for us is it gave truck braking brains and sight. For 100 years before, braking was a mechanical function. Step on the pedal, wire moves, air flows, liquid moves, the brakes apply. Now we added an electronic control unit, the brains, and we added wheel speed sensors, which gave us the insight. More information into the system. As we move forward, we add additional sensors. So stability, we added a steer angle, lateral acceleration, and yaw rate sensor. And we were able to have full stability or electronic stability control. In 2009, in our evolution, we added a radar that gave us wingman active cruise with braking, or adaptive cruise control as it's generically known. Now we're not only helping the driver in stability situations, because the system's built on top of stability, but we're helping them in maintaining a safe following distance behind a forward vehicle. Add some more intelligence to the system, and we get Wingman Advanced in 2011. Now we have adaptive cruise control and collision mitigation to help the driver. And then finally, last year in 2015, we added an additional sensor to the system, a camera and a radar that work together to help do more to help drivers mitigate collisions. So for example, with Wingman Advanced, we were pretty comfortable giving the driver an alert on a stationary vehicle. With Wingman Fusion, we're more confident that we will brake for the stationary vehicle.